you know, they are basically, essentially they are, how do I put this? They are like communication specifications. Yeah, so it's a specific way of saying that open communication, and it's all virtual. You know, really nothing is getting created. You know, yeah. But we have to find a way to do the if Edwin was here, would tell us more about like Unix, Linux amounts and volumes and how that all works. So again, you can check that on the internet how that is created. It's really awesome how, what you can do, you know, and specifications to create different volumes. It's the same thing, you know, when you got your disk and you got different file systems, and basically the specs showing, you know, all specifying how your bits and bytes and whatnot is all stored on your disk space, yeah, or on your disk, maybe not disk space, yeah. Now I don't have anything. It's all cleared. Okay, so I got this quick tutorial that I got out of the net here. No, I can do this. Not this one here. No, it's about info skills here. So again, really nice tutorial here. Just reminding us. Okay, I can see that now very visible from the Clive tutorials. And something that we can maybe go through, building an image. We saw how to do this, running an image and creating a container, running an image while attaching a volume. So we doing the -v, and we got our image, we mount it, and then we run the command. Run an image with an interactive terminal using -it. I think what I wanted here again is, you know, working with the volumes. So the description is that volumes are used to manage data in Docker. That's what we just discussed. And by default, the data in the container will not persist when the container is destroyed. Okay? As such, we store our input and output files from the containerized software in a directory on the host machine, which we attach as a volume. So even when the container is stopped, the file will persist. Okay, so the file still lives on. And we use the -v command to attach our file to the volume potentially that we've created. So let's just go through this here. So we got docker run -v, which is volumes, and this is the absolute path. This is exactly where your actual working directory is, and then we're going to mount it onto the path where your container, assuming that you got a specific container on an image, software lives and works, and and then you can run your command. You run your image, and then the command that you want to run. And I got a sort of a spec here that I can show you. So in here, what I wanted us to do, I did run into some headwinds here, is to pull a container. So for example, this is a next align, which is really awesome, really fast alignment program. And we can create a volume, and we can run Docker, right? And mount our volume and persist data on here. But I'm not quite sure what operating system this runs on. So when I run that, for some reason it can't see my my ref sequences. I thought that would be quite easy, but if not, I can use this example here. We can run this if we need to, which will do the same thing. So here, let me see where that was. They want to use that. Yeah. Docker run -v. Leave Docker. But before I continue, do we get the concept? Khadija? Who else is on the slightly mode?
Having something that is an actual
Practical.
while you're doing it, because
Okay.
yeah.
Yeah. I did want to talk a bit, I don't know what time it is, but I did want to talk a little bit about singularity. And I thought I'll just go straight to the materials. Yeah, it's all done here.